Okay, hi viewers and my subscribers, you are welcome to my channel. Today's topic we're looking at fractional precipitation. So one of the applications of solubility products concept is in the technique of removing some ions from solution while leaving ions with similar properties in solution. So I'm going to define fractional precipitation. Fractional precipitation is a process in which two or more different kinds of ions in solution are precipitated out of solution due to differences in their Ksp value. So look at, we're going to consider a solution that contains the following ions. So let us consider a solution that contains halide ions. You can see chloride ion, bromide ion, iodide ion. So when these ions react with silver ion, so silver ion, that's any soluble sort of silver. That's silver 2035. So when this solution that contains chloride ion, bromide ion, iodide ion combines with react with silver ion, silver chloride will be formed, and this is the Ksp value. Silver bromide will be formed. This is the Ksp value, and the silver iodide will be formed with the Ksp value 8.5 times 10 to the power minus 17. Okay, look at this. Which of these will be precipitated out of solution? So look at the respective Ksp value. The one with the lowest Ksp value is the one that will be what? Precipitated out of solution. Take note of that. In case if you are asked, if you are given an MAP, you are given something like this, and I ask you arrange this in an order, starting with the one that will come out first, that will precipitate out of solution first. So the one with the lowest value of Ksp value will be precipitated out of solution. Silver ion with the lowest value of Ksp will be precipitated out of solution, followed by silver bromide, and lastly by silver chloride. So let's look at this exercise on the board. This video for the first time, or this is the first time I'm coming across this channel, please hit the subscription button, like this video, share it so I get more people. Thank you. A certain amount of silver, solid silver 2035 was added to a solution that contains 0.04 molar concentration each of potassium bromide, potassium chloride, and sodium iodide. Calculate the concentration of silver ion that will be required to initiate the precipitation of silver chloride, silver bromide, and silver iodide. 2. Calculate the percentage of silver iodide precipitated before silver bromide precipitates. Like we saw the first thing that I did before this thing. If you are given a Ksp value for silver bromide, silver iodide, and silver chloride, you look at the one with the lowest value. So that's the one that precipitates. So they're asking you to find a percentage of silver iodide precipitated before silver bromide. So this is their Ksp value of silver chloride, silver bromide, and silver iodide. Alright, let's start with the first question. We want to calculate the concentration of silver ion that will be required to initiate the precipitation of silver chloride. So let's start with silver chloride first. So what happens is that when you react silver 2035 with 0.04 molar concentration of potassium chloride, the precipitate that will be formed there is silver chloride precipitate to be formed. So solution. So let's Ksp. If you write the Ksp value for this, you have silver iodide times chloride ion. So at the Ksp value, we are given 1.8 times 10 raised to the power minus 10. So this is the equilibrium expression for silver. So I'm going to make this one sort of formula. I'm looking for the silver ion. The concentration of silver ion is what I'm looking for. So I'm going to make this one sort of formula. So it will now be silver ion is equals to 1.8 times 10 raised to the power minus 10 divided by What is the concentration of a chloride ion? So this is 0.04 molar concentration of potassium chloride. So that's coming from, that's the chloride ion. So this the value is 0.04. 0.004. So the silver ion, the concentration of silver ion that will be required to initiate the precipitation of silver chloride is 4.5 times 10 raised to the power minus 8 molar concentration. So we're going to do the same for silver bromide. For silver bromide, Ksp is equals to silver ion times bromide ion, and the Ksp value is 3.3 times 10 raised to the power minus 13. So I want to make, we are looking for the concentration of a silver ion that will be required to precipitate silver bromide. So we're going to make this one a sort of formula. So 3.3 times 10 raised to the power minus 13 divided by what concentration of potassium bromide, that's 0.04. 0.04. So when you divide this, you're going to be having you'll be having 8.2 times 10 raised to the power minus 11. So we'll do the same for silver iodide. So Ksp is equals to silver ion times iodide ion. So what's the Ksp value? Ksp value is 8.5 times 10. That's 0.125 times 10 raised to the power minus 14. Alright. For the result of what we have, here, you can see the concentration of silver iodide is the lowest. So silver iodide will precipitate first when the concentration of silver ion is greater than 2.125 times 10 raised to the power minus 14. Followed by silver bromide will precipitate out when the concentration of silver ion is greater than 8.2 times 10 raised to the power minus 11. Then silver chloride will precipitate out when the concentration of silver ion is greater than 4.5 times 10 raised to the power minus 8. So let's look at the sum. Question number 2. Calculate the percentage of silver iodide precipitated before silver bromide precipitates. So first of all, we are going to find the concentration of silver iodide that is left in solution. That's the one that's not precipitated. So the formula is Ksp value of silver iodide all over silver ion required to precipitate silver bromide. So this is the Ksp value for AgI. Then all over the silver ion, that one, the first one calculated silver ion concentration needed to precipitate silver bromide. So concentration of silver ion, iodide ion is equals to, so what's the Ksp value for silver iodide? 8.5 times 10 raised to the power minus 17. The concentration of silver ion needed to precipitate silver bromide. So the value is, we got it to be 8.25 times 10 raised to the power minus 11. So when you divide this, you'll be having 1.03 times 10 raised to the power minus 6 molar concentration. Good. So now we're going to look at the percentage of iodide ion not precipitated. So the formula is iodide concentration not precipitated divided by the original concentration. What's the original concentration? From, that is 0.04 molar concentration of sodium iodide. So that's 0.04. So we have 1.03 times 10 raised to the power minus 6 divided by the original iodide concentration, which is 0.04. So when you do this, we're having times 100 times by 100. So you have 0.026%. So remember the question says calculate the percentage of silver iodide precipitated before silver bromide precipitates. Calculate the percentage of silver ion precipitated. So this one is the percentage of silver iodide not precipitated. So how do we get the one precipitated? So percentage of silver iodide precipitated before silver bromide precipitates. Precipitate will be 100 minus this value. So 100 minus 0.026%. So the value will be, so look at this. So percentage of concentration of silver iodide precipitated before silver bromide precipitates will now be 100 minus the one not precipitated. So it will now be 99.97%. So it means that 99.9% of silver iodide precipitated before silver bromide precipitates. You can do the same. If you're asked to find the percentage of silver bromide that precipitated before silver chloride precipitates, using this formula, you can still get it and find that one. I think you can find the percentage and post it in the comment section. Do that one for yourself. Calculate the percentage of silver bromide precipitated before silver chloride precipitates. So post the answer in the comment section.